go off. Okay, so 1.7b, rational functions and end behavior. So we're going to try and do this without a calculator. So there's no, if you look at this next 2 pages, there really isn't any graphs to look at. So if we didn't have a calculator, okay, how would we find the end behavior? That's what it's asking. Okay? Pardon?
I already did it.
No. So what did we find yesterday? That asymptotes, but that was all from a graph or a table, you know. But it was all like we had graphs, we had pictures. See all the pictures? Yeah, there was tons of pictures. Now it's just straight up just the equation. Okay, and we're pretending we don't have a calculator. So, do you notice on end behavior that this is what letter? X to negative infinity and x to infinity. So could I put x in place, could I put infinity in place of x?
Yes.
Yeah, that's kind of what that means, okay? So, how this works is if I want to determine the end behavior, okay, I am going to focus on just the leading term of each polynomial because they kind of, if you remember from all of the beginning of the chapter, like that kind of tells you everything, doesn't it? If it's a squared, that's a parabola. If it's cubed, that's a cubic function. If it's 4, they're either going up or down, right? That leading term. Good? Mm-hmm. Awesome. Okay, so we're looking at just the 2 leading terms. Okay, so what you're going to do is you're going to write them 2x over x squared, and then you're going to simplify. So what would that be simplified?
2 over x.
2 over x. Fantastic. Okay, 2 over x. Perfect. Another answer?
Yes, please.
Okay, so now, there's only 3 options, and you're going to want to memorize them. But if you forget them, here's a little way to remember it, okay? And it's kind of cheesy. But if you think of money per person, okay? And if I put in infinity for x, okay? So down here, I'm going to put in negative infinity for x. So what is 2 divided by negative infinity? So think about money. $2, let's say. If I had $2 and I divided it by negative infinity people. So think about $2, my 2 little $1 bills, and I had to divide it by infinitely many people. How much money will you get?
No money.
No money. You're not getting anything, are you? I mean, you're getting like a tiny, tiny, like 1/1,000,000th of a penny. Not even. Okay? So what is that? 0. Okay? So, and it would be the same. If I took $2 and divided it by infinitely many people, that would also be 0. So, you either have an end behavior that reaches 0, okay? So it says the polynomial in the denominator dominates the polynomial in the numerator in this instance, okay? The denominator is bigger, so that one dominates that. Okay, so let's do the same exact thing for example 2. Same exact thing. We're going to focus on the leading term. So you're focusing on the leading term. So what's x to the third divided by 5x squared?
X over 5.
X over 5. Okay, and it wants my end behavior, so I got to write out those ugly limits again. So the limit of x to negative infinity and the limit of x to infinity. And this is, my function is g of x. Okay, so think about this whole money per person thing again. Money per person. If I had negative infinity divided by 5. Like, think of money, and you had negative infinity money, and you're dividing it by 5 people. It's going to be just negative infinity, right? It's going to go on forever. We would all have infinitely amounts of money. So you can kind of tell what the rule is. Like, when the x is in the numerator, that's going to be infinity because you're dividing infinity into a number. And when x is in the denominator, you're dividing by infinity, so that's going to be 0. Okay, these are 2 instances, and this is the third. The third is the easiest, I will say. The third is the easiest. So what is the third one?
2 over 0, 2 over 0, yeah.
Not 0.
Is it not a function then?
Over 1.
T, when you get 2t divided by t, these
it's
cancel
2.
out and you're just left with 2.
Oh, it's just 2?
Yep, it's just 2. So that is like, if you remember yesterday, when the asymptote, do you remember the asymptotes? When they were at 2, like this one kind of, that is what that is. Okay? So my end behavior went to -2 in both of these instances. My end behavior went to -2. So this one would look similar to that. So when I'm doing my end behavior, my limit of x to infinity is going to be 2, and then negative infinity is also 2.
How come you didn't write the T thing?
Oh, because I forgot it. Thank you.
No,
Michael?
I was confused.
Thank you very much. I forgot the function. Don't forget the function. Okay. Now, this is your little cheat sheet. Okay? So, what this is telling you is if the degree of the denominator is bigger, so look at the degree of the denominator. So what does that mean? Degree of the denominator is bigger. So if you have like 4 over x, right? If you have the degree of the numerator is bigger, x over 4, and if the degrees are the same, 4, okay, you are going to have a horizontal asymptote. That's all that means. You're going to have a horizontal asymptote. It's pretty easy, okay? So how this works, so for this first one, that would be what? 4 over x, okay? And if I divide by infinity, if I divide by infinity, what's my limit? 0. So my horizontal asymptote is just 0. Okay? That's going to be like your little graph. You don't have to draw this, but your little graph is going to look like that maybe, and like that. And your little end behaviors are hitting at 0, and that kind of causes that to be a horizontal asymptote. Here, what's this one? X over 4. Okay? So yes, this one is infinity because I'd have infinity divided by 4. So infinity goes where? Like up and down, right? So there is no horizontal asymptote. So that would be like if this graph, and then if you, like what we did yesterday, where the lines like went like that, where they're going up and down.
Isn't the degree of denominator is bigger? It says horizontal asymptote equals that.
What?
Up on the top.
Well, that's just saying that you can have a horizontal asymptote with these 3 instances. But then this one is a none because it's going both directions, positive and negative infinity. So this one right here has none. Okay? We'll go into it more though. So then what about this one? When they're the same? Not 3.
1/3.
1/3. Remember, when you cross the x's out, you have to keep that. You have to keep that. What is that? A placeholder. So then, what's your horizontal asymptote? y equals 1/3. I shouldn't say you have to have one. Is that what tripped you up, Kenrick? You don't have to have the horizontal asymptote, but these three instances do. And that one is a none. I know, it's weird. You'd think it would have one since it's in here. Okay? So this part right here is, I know, is the mathematical jargon. So do you see how n and m are the exponents? No. When n is less than m, y is a horizontal asymptote. When n is greater than m, it has no horizontal asymptote. And when they equal each other, it's just the two numbers divided by each other. That's like the mathematical, what I just kind of explained on the last little,
So what's about the
Thoughts?
extra stuff?
I know, isn't that, it's just all,
It's a bit of.
it's
bit of
just telling you
stress.
like what a polynomial could be. It could be long and ugly like that. Okay, so example 4, can you do this? You have to tell me what is the limit. They've already written the limit notation. And instead of an f of x, they just plopped the equation in there. Does anybody know what it would be? Yeah? Perfect. So 2x squared over x squared, so this would just be a 2. So what would the horizontal asymptote be? Y equals 2. Y equals 2. That's going to be a line across 2, like a dotted line. Easy, right? Kinda? Sorta? Okay. What about this next limit? Okay, so this one gets a little bit tricky. So if you have 3x cubed over x squared, that's going to be 3x, isn't it? Okay. So what does it want my limit to be? Negative. Do you see down here it's a negative infinity? So if you're ever like struggling, remember, you can take this and plop it into that. So if I did 3 times negative infinity, what would you get as your answer?
Negative infinity.
Negative infinity, not positive infinity. So this one is a little bit tricky because they're only asking for the negative side. They did not ask for the positive side. Did you notice that? They're only asking, in both of these instances, they're just asking for one of the limits. Okay, quick practice. So number 1, can you find the end behavior? Keyword, end behavior. Ends. So you're looking at the ends and they want it in limit notation. Okay, what'd you guys get? What? Okay, so when you highlight this, the t's, one t cancels out, so you're left with t over 4. So t divided by 4, if I put in negative infinity in there, what's negative infinity divided by 4? It's just going to keep going to negative infinity, isn't it? And then positive infinity divided by 4 is just going to go to positive infinity. Next one. Find the horizontal asymptote. So what's x to the 4th divided by 4x to the 5th? 1 over 4x. So if I put infinity down there, no, they want the asymptote. So what would the asymptote be? Where is that headed? First, think about if you had limit behavior. So like if you put in an infinity in there, okay? If you had infinity in it,
0.
okay, 1 divided by infinity. If I have $1 divided by infinitely many people, that's going to be like nothing, right? It's going to be 0. So then your horizontal asymptote is just y equals 0.
Yeah, I'm really sorry.
We actually kind of do
Is it just, if there's.
that. Yeah, that's like the first one.
Well, it's the same as your limit. It's essentially the same as the limit, is the horizontal asymptote.
Because you can't get to 0.
Yeah, and
They put infinity.
a horizontal asymptote isn't gonna be, like these wouldn't have a horizontal asymptote because it's going on forever in both directions. This one, since it's reaching 0, that's where the asymptote
How do
is.
you get from 1/4x to just y equals 0?
Because it just
It's
asked.
putting, like, any infinitive
It
number
said ask
x.
for the horizontal
So it's
asymptote.
keeping, like, small, but never reaches 0.
Yeah, if you had $1,
Yeah.
dollar divided by 4 trillion people, you'd get like nothing.
But it's never gonna hit 0, but it's gonna be like.
0.000002.
Denominator,
Huh?
because it's in the denominator.
Yes, yep. Okay, this one's a bit of a trick. What do you guys think?
It's 3 I don't get it.
Yeah, but it wants the limit. It doesn't want, so here, yes, it's 3n squared. But what limit is it asking
Oh,
for?
it's gonna be positive. I got it.
Negative and
Okay, it's asking for negative infinity. So if I put negative infinity in there, that would be 3 times negative infinity squared. Negative infinity times negative infinity is positive infinity times 3 would be positive infinity is the limit. So we didn't use our calculator, so try not to use your calculator. One thing real quick I want to talk about, okay? So can you guys, I think we can turn, if you turn back to page 5, this whole as x increases without bound and when is the interval increasing and find the y-intercept. Some kids have been struggling with that, so I kind of wanted to talk about it real quick. Okay? Did you guys do this problem yet? On page 5? Okay. So we can do it together. Okay. So, what is my, if I'm on A, state the domain. I feel like you can do that. Are you guys good with the domain? There's 2 asymptotes, isn't there? You see the asymptotes? Positive 2 and negative 2. So what would the domain look like? So go on the x-axis. Pretend you're walking along the x-axis. What? Negative infinity to negative 2. Union. Negative 2 to 2. Union. Fantastic. Find f of 9. You got a 1?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9. Go up. Perfect. 1. Okay, so finding the y-intercept is easy on a graph, isn't it? But what essentially does that mean? You want x to be 0, don't you? So you want x to be 0. So like on today's homework, they're going to ask it, and they're going to ask it with like an equation, and they're going to want you to find the y-intercept. So all you have to do is put in 0 for x. So you're putting in 0 for x, and then you'll be able to find what would be the y-intercept here. If I put 0 in for x, so that becomes 0 minus 0 minus 24. And what's this as a 0? 0 plus 0. What's anything divided by 0?
It's 0.
Nope,
Nothing.
nope,
Infinity.
nope.
No.
What's the word? Guys, we're in an AP math class. We need to know the words.
Undefined.
Undefined, yep. Perfect. Okay. State when, okay, increasing, decreasing, I feel like you can do
The
that.
answer for C is just x equals 0?
Huh?
Is the answer for C just x equals 0? Or is it negative 2?
Wow.
No, you have to find when x is 0,
So
yeah,
it's negative 2.
yeah.
So it's just 0.
Y equals -2. This is the other one I wanted to talk about. As x increases without bound, what's happening? This is only, so if it, what's your limit? What's your end behavior? 0. So it's just this, it's just that, it just approaches 0. So when they say that, it's kind of like they're asking you, okay, you just told me the limit is 0, but what does that actually mean? And that's what that, as x increases, so x, as x, so stop and think about it. As x increases, right, these numbers are 2, 3, 4, 5, 6, 7, 8, 9, 10 on the x-axis, right? Without bound, meaning it's gonna go on forever, right? That could go out to 2,542. Yeah, okay? It's going to get closer and closer to 0. That's all that's asking. Like, do you know what's happening? That's all it's saying. Okie dokie. All right, it's your turn. Now you have time to work. Okay?